here today with Scott Stevens from Palo Alto Networks, and we're talking about security. In particular, we're talking about 5G security. And one thing I'd like to get a bit of perspective, this move from, we're in the transition from 4G to 5G. The core of the network is changing, and I feel like people have kind of underestimated what a massive technology change and really like ripping out the heart of the network and changing it over. In the when it comes to protecting networks, that has to upset something, change things around. What's your sort of perspective on what's changing and how to best protect the network that we're going to have when we go to 5G?
I think there's two different aspects for us to think about when we consider sort of the evolution from 4 to 5G. So to the first point, what you're talking about is we're changing out the EPC to the virtual EPC. And we're moving a lot of what used to be proprietary, standalone sheet metal that was running these networks, the S gateway, the P gateway, all the other aspects of that. We didn't really focus much on securing them in the past. One, because, well, back in 3G and 4G, we weren't quite as worried about security in general in the mobile infrastructure. But two, those operating systems were proprietary. The whole software stack was integrated by a single company. And so a lot of the burden was placed on the manufacturer to make sure that they had a secure platform. But if we look towards the shift to virtualization and leveraging cloud technologies, the world changes on us now. So we get great scale, we get much better economies, and so we're going to see really nice services and really nice expansion with IoT and all the mobile devices that we're going to see in 5G. But we're now running in standard operating systems on a hypervisor and virtualized platform. So we've got a Linux layer, we've got a hypervisor layer, we've got the x86 processing layer, all the things that provide the scale, as well as the software now that's been rebuilt for these open operating systems. So if you think about it, instead of a single vendor who is responsible for security, you have four.
Yeah, and they all have to hand off the responsibility at some point, right?
Right, and so vulnerabilities exist at all kinds of layers, right? We announce vulnerabilities in Linux, in hypervisors, in operating systems, and that's normal. That's the state of modern software. But how do you manage that as an operator if you have to upgrade each one of these at different periods of time, and how do you manage that consistently? And how do you keep up with those different vulnerabilities? Because now the burden has shifted to the operator. So we're doing a lot of work with providers around the world right now where how do we protect that whole virtual EPC from all the dirty aspects of the 5G network, or 4G even, and maintain the purity of that clean part from all of those vulnerabilities at all of those layers. So we can do that from a network security perspective, protect the Linux core, protect the operating system, protect the hypervisors. We can make that happen, but we have to think about it, right? And the operator has to look, or even the manufacturer has to look to design that into what they're doing now from a security perspective, which again, they didn't really think about before. But with modernization, great opportunity, but also we have a new surface area of attack that we need to take care of.
That's what I was sort of thinking about it from the operator's point of view. Not that they didn't pay attention to security before, but like you said, it wasn't as top of mind. The threat, the modes of attack have now advanced. The types of threats have advanced, and of course, the surface area is a lot larger, and there's more vulnerabilities. When a carrier is looking to design security into the 5G network, why is it almost, maybe I should rephrase, is it enough to just wait on the standardization and have the standard security baked in? Do you need more than that?
Standards, from a security perspective, I think standards are important, and we're working with GSMA and working on the standards to try and help figure out what we need to do moving forward. That said, standards typically lag an understanding of where the risks are. And if I look at some of the bigger challenges we're dealing with from a security perspective today, it's the unknown or the unintended that become great risks. And so standards tend to lag that. So yes, we need standards and we need to design to the standards, but I think we actually need to do better than that. And if we think, we talked about the virtual EPC here for a moment, but let's extend this to the overall 5G infrastructure. When we built 4G or 3G, it was the world of the flip phones. Right? We were in a different era. And so we didn't have concerns about infected devices in the network. We didn't have a proliferation of IoT. We didn't have malicious actors that were peering with service providers, and of course all the threats coming in from the internet. So the world has changed quite a bit. And so even if we move out from the virtual EPC, we need to think about a more holistic security posture across the rest of the network. We did a trial with an operator here last year, and we were just at GI, and just trying to help give them visibility. And we've had security at GI for a long time, but we've had old, like port-based security in NAT.
Okay.
Right, and I guess the first rule to security is visibility. If you can't see something, you don't know what to secure with.
Right.
So we moved into a full layer 7 anti-malware position for them, just to help them get visibility. Over 10 days, we found 1 million infected devices on their network. They didn't believe they had any security problems.
Oh, good. So that must have been great news for them.
Well, it's challenging for their customers.
Yeah.
Right. We actually found a campaign that a nation state was running within their country to attack some of their critical infrastructure, because you could see the bots building in the mobile infrastructure. And so having that visibility becomes really, really key. And we're in the age when a smartphone is as powerful as a computer was just a few years ago. And so we have to think about them as these hyper-intelligent compute devices. That, of course, creates opportunity for exploitation of the device. And of course, the consumer, folks like you and me, we don't always do smart things with our phones, and we go lots of places. Right. And so the operator needs to take sort of a protective approach to help the customer understand when there's a problem, help them mitigate what have happened. Because it might just be a problem for the customer, but it might be something that's going to be used to attack the service provider.
Yeah, every single vulnerability kind of becomes amplified because of the power of the device. Now these things can be turned into things, devices that can really attack the network on someone else's behalf. Absolutely.
And so when we think about that visibility and that control, I think about the payload, right? I think about malware and the command and control within the malware, but I also think about the signaling layers. What do I see at SS7? What do I see at diameter? What do I see at the SCTP layer? And how do, GTPC, right? How do I connect together the signaling aspects of 5G, which are unique to 5G, with what's happening on the payload side, and see that connection? Are there connections now between infected devices and misbehaviors on the signaling side? To do that, you need to have one consistent view of security. And the history of security in the entire industry, I mean, let alone 5G, is over-siloization.
Yeah.
And so I think if we apply that, everything we've learned in the rest of the world back to 5G, if you do all those independently, it's difficult to connect them together. And so our approach has been, how do we give that visibility and that enforcement across all of the signaling layers as well as all of the payload layers, inspecting GTPU, for example, on the RAN or the roaming and peering side, so that the operator fully understands what's happening within their network, and with that they can decide what to prevent and what to block and what to secure, or what services to offer their customer. Because they have that visibility, they can be valuable to a customer who might have done something that wasn't so smart and gotten infected.
Okay. Similar topic, but related to yet another kind of hot area of development in the network now is that although it's happening in limited amounts, but people are building out the edge of the network. They're building out edge computing for media applications, for offload, and eventually there's going to be we feel like a boom in private LTE networks as well. How does that change the security, I guess, the threat surface, but also the security solution side that like Palo Alto provides when we're pushing more and more capabilities closer and closer to users?
I think what we're effectively doing, we can use the word data center or cloud, but what we're effectively doing is moving small parts of the cloud closer to the user.
Right.
And so everything we've learned about securing data centers or securing clouds over the last decade, we need to reapply in this MEC, or this distributed edge compute function. And so those are typically, back to our earlier conversation about the virtual EPC, these are virtualized environments. And so we need to make sure that we can protect all the different layers that exist within that environment, but inspect everything coming in and out to make sure that those applications are communicating as they should, and that unintended things aren't happening, and that we don't see malware or command and control transiting in and out of these locations. So again, these are the same rules that we apply if I'm helping a customer who's moving their compute into Amazon or Azure or GCP. These are the same rules we need to apply at the MEC. The MEC's going to be smaller, but there's going to be many, many more of them. So we have to be highly scalable, we have to be simple to configure, we have to be fully cloud enabled and enabled by APIs. So how do you quickly spin up, spin down, and move? Those are all things we've learned over the years that I think we can use to help scale all of these distributed clouds, whether it's the virtual EPC cloud, whether it's the MEC cloud, whether it's GI LAN or the application cloud that's deeper in their network. All of those need to be secured that same way. And so being highly automated and able to adapt at layer 7 and understand the threat surface, not this old world of port-based security doesn't mean anything anymore.
Right.
A port is an approximation for what the application might be.
Yeah.
So securing at that level doesn't make sense anymore. We really need to be far more intelligent about what we're doing.
Okay, so more intelligent security, higher visibility, and then of course the capability of knowing that what you've learned before in the data center and the cloud applies to this new world of edge computing.
Absolutely.
All right, well thanks so much for speaking with us today. I appreciate it.